All right, finishing up with chapter 8 right now. We saw chapter 5 after this, but chapter 5 is going to feel like a walk in the park after we do this one. This is the last super difficult, probably review, chapter 8. Chapter 6 was probably the worst chapter. Chapter 8 was right behind it. So let's get it over with, but I think you'll surprise yourself at how well you're going to be doing with now with chapter 8 when we just kind of like simplify it down to its like bare bones minimum. What is the relationship between the values? Is it direct? Is it inverse? Or neither? Write an equation to model it if it's direct or inverse. We cannot write an equation if it's not. So what we're going to go through, guys, is we're going to see if there's a pattern. So let's grab my calculator. And do a quick screen share. Try that again. There we go. That to be too large. All right. So what I notice about the absolute values of these numbers is that x is going up as I read my chart and y is going to go down. So that means I'm going to test for inverse. And I know that inverse is y equals k over x. So if I solve for k, if I'm testing for k, I got to do y times x. So I'm going to do 0.1 times 3. I'm going to do 3 times 0.1. I'm going to do 6 times 0.05. And I'm going to do 24 times 0.0125. All right, they all equal 0.3 when we multiply. So I'm going to write all equal 0.3. Oops, all equal 0.3. So I'm going to say that this is truly inverse. It does test out. And I'm going to write that y equals 0.3 over x. If you really want to be mathematically proper, we probably should write y equals 3 over 10x because most mathematicians don't want a decimal inside of a fraction. But honestly, I'm happy with either one of these. Oh, that's a terrible highlighter. I won't use that. Let's use orange on top of orange. That looks better. All right, let's check out the second one. I noticed that the values of x are increasing, the values of y are increasing. I'm going to test for direct. Since direct is y equals kx, the test is y over x. So I'm just going to do 3 divided by 1, 6 divided by 2, 5 divided by 15, 18 divided by 6. Yes, every time you do y divided by x, you get 3. So I can say, yes, it is direct for sure. I did my test. And I can say y equals 3 times x. Now I did that pretty fast. If you were not able to keep up or you did not understand, please rewatch that video. That's the benefit of being able to do this way. Please rewatch, make sure you understand why one is inverse and why one is direct and how I got my equations. The next thing I'm going to do, absolute value-wise, x is increasing and y is also increasing. This cannot possibly be inverse. It must test for direct. And that is a possibility. So I got to take all my y's and divide by my x's. 1 divided by 0 is no good. Okay, so right away I notice that's no good. If you even wanted to go as far as to test for inverse, you can multiply them, but they're not going to give you the same thing. This is not possible. Like even if you wanted to say, okay, the 0 one's weird. What about 5 divided by 2 and 7 divided by 4? Not getting the same number. This one's neither. So I did one of each of these for you. So in case, depending on which one pops up on your final, you're ready for either of them or any 3 of them. Number 2, describe it. That's modeled by this formula. So what we're going to do is we're going to really zoom in here. We have F on the top. That's usually associated with the word direct. We have M on the bottom. That's usually associated with the word inverse. So let's see. A varies. That's good. Directly as F, inversely as M. There we go. That was easy. Yeah, no other one has the correct, and D is super wrong. So yeah, we'll just go ahead and go to number 3 then. Divide, stating restrictions on the variable. So this is dividing polynomials. This is from chapter 8, section 4. We need to factor the tops and the bottoms. I should use my bigger words. Factor my numerators and my denominators. We're going to flip since it's division. This is division, so the second one needs flipped. And then we'll cancel anything that matches on top with anything that matches on the bottom. Now, if you are a grouping person, you should pause the video and factor each and every one of these. If you are a boxing person, you should pause the video and factor every single one of these. If you are a guess and check person, you should pause the video and factor every single one of these. This is going to be up to your student responsibility. If you cannot factor these, please email me. We have to meet after school. You have to be able to factor going into your final. I'm going to color code them. Orange, green, red, purple. Hopefully you took the time to pause the video. When you factor this orange one, you get x plus 4 and x minus 4. This is the difference of perfect squares. When you factor the green one, you get x plus 3 and x plus 2. When you factor the purple one, you get x minus 4 and x plus 2. When you factor the red one, you get x plus 1 and x plus 4. So I factored everything that could possibly factor. You are not going to look at the old items anymore. Don't look at that, don't look at that, don't look at that, don't look at that. Notice the factoring was not overwhelmingly difficult. I'm concerned about your steps right now. Now, I do have to flip the purple and the red. I'm going to rewrite my problem because I think it's getting very messy. So I'm going to do x plus 4, x minus 4 from the first fraction, x plus 3, x plus 2. I'm just going to extend my fraction bar. I'm going to put the red on the bottom. This goes down. X plus 1, x plus 4. I'm going to put the purple on the top. X minus 4, x plus 2. Now anything that matches top and bottom gets to cancel. That's it. That's unfortunate. I was hoping some more would cancel. So my final answer, I don't know why, it's not like it really matters, is x minus 4 squared, because it happens twice on the top, x plus 3, x plus 1 on the bottom. Now, it did ask us to state the restrictions on the values, or the restrictions on the variables. That is where you set each item that was in the bottom equal to 0. Remember that was from chapter 8? So this one, this one, this one, this one, and census division, this one and this one. You need to look at your chapter 8 notes right before, I do believe, Thanksgiving break. It was like an added section for you. So this one, if you set it equal to 0 and solve, x cannot be negative 3. This one, set it equal to 0 and solve, x cannot be negative 2. This one, x cannot be positive 4. This one, x cannot be negative 2. Up here, that top red one, you can't see where I'm pointing. There you go. X cannot equal negative 1, and here x cannot equal negative 4. Now, if I repeated any, it wasn't necessary for me to repeat them. I was just, so I didn't have to write negative, I didn't have to write negative 2 twice, but those are the restrictions. Number 4. Multiply this. So what I want you to see now is we're going to do the exact same problem, but we're changing the directions to say multiply. I want to show you the difference between them. Good news, since I didn't change the problem, the factoring is still the same. So this is still x plus 4, x minus 4. This is still x plus 3 and x plus 2. I just want you to see the difference between division and multiplication. This is still x minus 4 and x plus 2. This is still x plus 1 and x plus 4. But I don't have to flip it because it's not division. So the red stays where it is and the purple stays where it is. So you just cancel as is. So what matches top and bottom? Not much. X minus 4 cancels with x minus 4. And that's it. So the difference is you don't flip, you just cancel right away. So it's x plus 4 on the top. I think x plus 4 happens twice on the top, and x plus 1. And on the bottom, x plus 2 happens twice. You can write it twice if you don't like swearing it. The restrictions on the variables are a little less this time. They'll just be here, 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 and here. Because it's not flipping upside down, you don't have to worry about like the red at all. So your restrictions on your variables are negative 3, negative 2. What was this one? Positive 4 and negative 2 again. You don't have to write the negative 2 twice. All right. So we added, or silly me, we divided, we multiplied, and now believe it or not, like back in elementary school, adding and subtracting was easier than multiplying and dividing, not with fractions. So now let's go ahead and do a subtraction problem. So the first thing we do is we factor the denominator. Well, pause the video and factor it, and then come back. Welcome back. You should have got b minus 1 and b plus 2. And then the second one does not factor. And I guess I could probably factor the numerator, but let's see. Does that factor? Would it be helpful to factor? Let's check it out. It would be b minus 4 and b plus 2. Oh, that really would help. That does not always help to factor the top. I'll say that again. It does not always help to factor the top. It just so happens that in this problem, the reason it helps is because we can get rid of this b plus 2 with this b plus 2 and have a much more simple problem. Okay, so I factored the denominators, done. I find the common denominator. In this case, it's just b. I thought it was going to be b minus 1 and what was that, b plus 2? But remember how our b plus 2 went away? It's not. So now we got to go do like the missing step. What's like I call it the bubble step. This one has a b minus 1. This one has a b minus 1. P.S. 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 If you did not know that the b plus 2 canceled out, this guy would have needed a b plus 2, and you would have had to distribute a negative 6. Okay, you would have got the same answer, it just would have been a lot more work. So this is the carry it over step. So the first bubble is b minus 4, minus 6, nothing else in that bubble. Distribute anything that distributes. There's nothing actually distributes in this one. It's just like the parentheses drop off because those first parentheses are useless. Like I said, if you had forgotten about the b plus 2, you would have to distribute this 6 through, and it would be a lot to take in. Okay, but you didn't need to because we remembered. So it's b minus 10. Now I'm going to go ahead and throw my common denominator, which was way out front, b minus 1, put that here. Please do not think that the b's cancel out. That is all done. So this time an expression is your answer when you divide. No, I was going to get a drink of water. I don't have any. That's all right. We'll finish up here and then I'll go. Let's go ahead and add this time. Pause the video and factor top and bottom. Let's see if it makes a difference this time to factor top and bottom. Welcome back. I hope you took the time. You should have got not B. We're on W's. W plus 6 and W minus 5. And let's just see what this one was. Did you get W plus 6? Oh, that will be helpful. And W minus 4. That actually is really helpful because those cancel. P.S. That is not always going to happen. Again, one more time, I'm going to say that is not always going to happen. If it doesn't happen, leave. If nothing does cancel, please leave the top like this. If nothing cancels, please leave the top like that. Okay. Now it's time for us, and then that part didn't factor. It's time for us to get a common denominator, which is conveniently the only denominator of W minus 5. And now we are on the bubble step. So I could have rewritten this because it is getting a little messy, isn't it? I'm going to rewrite it. W minus 4 over W minus 5 plus 8 over W minus 5. So this, remember the common denominator was W minus 5. That has a W minus 5. That has a W minus 5. Again, if you would have missed like the factoring and stuff, or if something would have canceled, that 8 would have needed something else, and you would have had to have remembered to distribute a positive 8 in the next step. But we got lucky on this one. I did not do that on purpose. If you need a harder example, there's your 2 bubbles. I carried them over. If you need a harder example, please email me or just look back at your Chapter 8, Section 5 notes. So W plus 4 was a bubble, it gets a check mark. 8 was a bubble, it had a check mark, so I don't bring anything over. I'll just lose the parentheses. The parentheses don't need anything distributed, so I can lose the parentheses, combine my like terms. The common denominator is W minus 5. Nothing factors, nothing cancels. That is our final answer. All right, how are we doing? Number 7. Number 7 wants us to solve. So that was Chapter 8, Section 6, Part 1. Believe it or not, even though it looks like it might be more difficult, this is actually easier. Ooh, I have a class in 6 minutes. Let's see if I can get this taken care of. Number 7 wants us to solve. So we've got a factor. Factor anything that factors. That does not factor. This does factor. That does not factor. Pause the video, please. Factor the middle. Welcome back. You should have a minus 3 and a plus 2. That should be all gone. Nothing in the top factors, plus it really would not have done anything really nice for us anyway. So we got to take a look at our common denominator, which is a minus 3 and a plus 2. Now we got to go to our bubble step. This needs a plus 2. Ooh, this has both of them. This needs a minus 3. So let's see, I'll carry this over here. I'll just write kind of small. I don't think I need my calculator at this moment. Let's see, pinch to zoom. There we go. So my first bubble box, whatever, is a times a plus 2. There's my first bubble. Then there's an equal sign. Then there's 7a minus 6 with nothing. It got a check mark. Then there's a plus sign. Then there's a 2. Then there's an a minus 3. Because this was an equation and not a expression, I do not need the common denominator. Whoop, whoop, that's so exciting. So now it's time to distribute a squared plus 2a. Let's see, what distributes over here? Nothing with 7a minus 6, but I do get 2a minus 6. Combine. Let's see, what's that going to be? 9a minus 12. Ooh, a squared. I know a lot of you know when you get a squared, set it equal to 0. So if you've got to set it equal to 0, do minus 9a and plus 12. A squared means set equal to 0. Combine your like terms. That's a squared minus 7a plus 12 equals 0. If I am going too fast, pause the video. Do a step, then come look at mine. Do a step, then come look at mine. Do a step, then come look at mine. If they don't match, try to figure it out. If you can't figure it out, come to the Zoom meeting. Can't tell me the Zoom meeting, watch the recorded Zoom meeting. Can't watch the recorded Zoom meeting, come to the tutoring time from 2:30 to 3. Ooh, okay. And just got an email I got to take care of. You guys can factor to solve that or use the quadratic formula. I'll just use the quadratic formula because it works every single time. So that's opposite b plus or minus square root of b squared minus 4ac all over 2a. Negative, oh, that's positive 7 because it's opposite b. Plus or minus square root of, let's see. And this is just a 1 over 2. Be 49 minus 48. Yeah. Oh my gosh, we're getting so close. Square root of 1 is just 1. Okay, now we'll add 7 plus 1 is 8. 7 minus 1 is 6. 4 and 3 are my answers. You do need to check both those answers back in. Ooh, and 3 would be extraneous. So these are what I get for A. 3 is what we call extraneous. And 3 is extraneous because if you were to put a 3 right here, you would get a denominator of 0. No good. But please go back and check in 4. I think 4 does work, but I have a class that starts in 2 minutes. I can check it later, but I'm pretty sure we're good with 4. A gardener completes a park maintenance in 12 hours. So gardener number 1. This is definitely a work problem. They're doing a job. Another gardener takes 10 hours. How long if they're working together? Okay, so the first guy does 1 park in 12 hours. The second guy does 1 park in 10 hours. This is Chapter 8, Section 6, Part 2 notes if you need to look this up. This is a work problem. How long if they work together? This middle column is how long it takes them together. That middle column is always together time. If you know it, then you put a number in there. And this last column is always these two together. So this would be 1x over 12, and this would be 1x over 10. And what's the question? How long will it take them if they work together to complete the maintenance? So we're still just talking about one garden. Here's garden guy number 1. Here's garden guy number 2. Here's the one garden I need to complete. Here's my common denominators. Now the bubble step. Bubble 10, that's what it's missing. Bubble 12, that's what it's missing. Remember, you always look at the front. And what does that one need? It needs a 10 and a 12. Yes, I am doing this maybe a longer way than needed, but it works. So that is 10x plus 12x equals 1 times 120. That's 22x equals 120. That's a calculator. Oh, I need to get to my meeting. So that's 120 divided by 22. So I get x equals 5.45 hours, and that is if they work together. I am going to start my meeting with this recording going on. Please read through the next problem. You can travel 40 miles on your motorbike in the same time it takes your friend to travel 15 miles on his bike. If your friend rides 20 miles an hour slower than you ride your motorbike, find the speed of each bike. We did do this one. This is actually directly from one of your homework problems. So you can try it on your own and come back to the video. Let me say hello to my class. Give me one moment, please. Hey guys, I will be right with you. I'm just finishing up a video. If you guys can please pull up your Chapter 2 and Chapter 3 review into Notability, I'd appreciate it. But I do want to finish up my video real fast. Thanks, guys. All right, you can travel 40 miles an hour on your motorbike. Here we go. This is a distance problem. There's you on your motorbike. Here's your friend on his bike. You can travel 40 miles. You know what? Hold on. Let me join the Zoom meeting. No, it's okay. All right, you can travel 40 miles on your bike in the same time that it takes your friend to travel 15 miles. So this is distance. This is rate and time. Your friend rides his bike 20 miles an hour slower. So that's your rate, take away 20, slower. And here's you. And let's set up our two equations. So I can do r times t equals 40. And I can do r minus 20 times t equals 15.